Now, yesterday, the first report about what it's doing closest to the sun came out. These are instruments that are capable of looking very close to the sun. And it was realized that, in fact, the object is brightening. It becomes very bright right now as it comes close to the sun, and it's turning blue. And the color blue is very surprising because if there is any dust shed off a natural nucleus of a comet, the dust would make it red. And usually the surface of the object is at least an order of magnitude cooler than the surface of the sun. But what the new data indicates is that the object is bluer than the sun. How is that possible?
This morning, we have a report that the object got much brighter than expected, and moreover, the color of the object is bluer than the sun. And that's very surprising because usually when there is dust around an object, it should make it red. I should also say that the news yesterday was that this object came closest to the sun, and it received a huge amount of heat from the sun. And the latest report indicates that it became extremely bright, much more than expected for familiar comets.
The James Webb Space Telescope has once again unveiled a revelation that defies expectation and deepens humanity's understanding of the cosmos. When astronomers turned its gaze toward an object known as 3I/Atlas, an interstellar visitor already wrapped in mystery, the results were nothing short of astonishing. Discovered on July 1st by NASA's Atlas survey, 3I/Atlas was initially believed to be modest in size. But Webb's confirmation shattered those early estimates. The object was far larger, more complex, and infinitely more intriguing than anyone had imagined. Its discovery has sparked excitement across the astronomical community, not just because of its sheer presence, but because of what it represents, a deeper, hidden diversity of worlds adrift in interstellar space. 3I/Atlas was already remarkable before Webb examined it. As only the third known interstellar object to enter our solar system, it carried the weight of cosmic mystery. Unlike the comets and asteroids that orbit our sun, remnants of our system's own creation, interstellar objects come from elsewhere. They are exiles flung into the void during the violent birth of alien stars and planets, wandering for millions, even billions of years between suns. Each one that crosses our path is a rare messenger from beyond, carrying within it the physical memory of a system far removed from our own. To study one is to touch another corner of the galaxy without leaving home. But Webb's observations revealed something far beyond expectation. Ground-based telescopes had suggested 3I/Atlas was small, perhaps comparable to a typical cometary nucleus, consistent with the two previous interstellar objects, Oumuamua and 2I/Borisov. Yet Webb's infrared sensitivity pierced deeper, detecting faint heat signatures that exposed a startling truth. 3I/Atlas was reflecting and radiating far more energy than a small object ever could. Calculations were revised. The object size was drastically increased, suggesting not a mere fragment, but a vast and complex structure. This realization carries profound implications. A larger interstellar body challenges long-held models of planetary formation. Until now, scientists believed that only smaller, icy or rocky fragments could be ejected into interstellar space during the chaotic youth of planetary systems. But 3I/Atlas tells a different story, one where even planetesimals, the very seeds of planets themselves, could be hurled out into the dark. If this is true, then the galaxy may be far richer and more crowded than we've imagined, not just with dust and shards, but with monumental travelers silently drifting between stars. The mere existence of such a massive body forces astronomers to reconsider the violence and generosity of star formation. And as Webb's instruments studied the spectral fingerprint of its surface, the mystery deepened. Reflected light revealed a strange blend of icy volatiles and dark, carbon-rich compounds, a combination hinting at a turbulent history of heat chemistry, and time. The preservation of these compounds on a body this large suggests it was born in a region abundant in both ice and complex organics. That revelation adds weight to panspermia theories, the idea that the building blocks of life might travel across the galaxy, carried by wandering worlds. If objects like 3I/Atlas are not rare exceptions, but part of a vast hidden population, then the possibility that life's ingredients drift freely through the cosmos becomes far more plausible. Its sheer size also redefines how we detect such travelers. Smaller interstellar bodies are fleeting, too dim to notice until they are already close and gone too quickly to study in depth. But a larger one lingers. It holds its brightness longer, shedding gases and light that can be tracked with precision. Webb's ability to measure and confirm its scale serves as both a triumph and a warning. The interstellar void may be filled with more of these massive visitors than we ever realized, awaiting discovery as our instruments grow sharper. The question then arises, how many more are out there? If 3I/Atlas represents a class of large interstellar wanderers, then our galaxy might be teeming with them. Colossal bodies tracing invisible paths shaped by ancient gravitational encounters with distant stars. For planetary defense researchers, such discoveries carry additional weight. While the odds of an interstellar body colliding with Earth are vanishingly small, their gravitational influence is not. A visitor of this magnitude could subtly distort the orbits of comets or asteroids as it passes through, adding unpredictable complexity to the delicate choreography of our solar system. Webb's revelation is a reminder of the telescope's transformative power. It doesn't merely refine our measurements, it redefines our assumptions. In the case of 3I/Atlas, it has turned a simple curiosity into a paradigm shift. Each new interstellar object no longer seems like an anomaly, but a new chapter in an expanding cosmic story. 3I/Atlas reframes our understanding of the galaxy itself. It suggests that the birth of planets is not only violent, but extravagantly productive, hurling vast fragments of potential worlds into the interstellar sea. Time, too, plays a vital role. These visitors race through our solar system on hyperbolic paths, offering only fleeting windows of observation. That Webb could capture such precise data in that narrow span is a testament to human coordination and readiness, a glimpse of how far technology and teamwork have come. Each new object becomes a test of our ability to adapt, to respond quickly, observe efficiently, and revise what we thought we knew. And with 3I/Atlas turning out to be so much larger than imagined, it sets the stage for future encounters where the unexpected becomes the norm. Every interstellar body is a piece of another system's story. If 3I/Atlas formed within a protoplanetary disk like our own, its preserved materials could reveal what we share with distant stars, or what sets us apart. Comparing its composition to that of comets, asteroids, and Kuiper Belt objects could map the diversity of planetary birth across the galaxy. Its magnitude ensures that such comparisons will not be trivial. The larger the body, the more representative it may be of the processes that shape entire worlds. But beyond the science lies something more human, a cultural and philosophical resonance. Humanity has always gazed upward with awe, searching for meaning among the stars. The knowledge that entire planetary fragments wander freely between suns makes the universe feel both more immense and more intimately connected. Imagine 3I/Atlas circling a distant star, ejected by some cataclysm, journeying through the void for millions of years before passing near our sun, a survivor of cosmic violence, bearing witness to the shared materials of creation. It is not merely a rock adrift in darkness, but a tangible piece of another world's history. Webb's confirmation of its true scale marks a turning point, a moment when science itself steps into a broader horizon. Rather than fitting into familiar categories, 3I/Atlas expands them. It hints that planetary systems across the galaxy may routinely cast out massive remnants of their formation, seeding interstellar space with colossal wanderers. It paints a picture of a galaxy more dynamic, more chaotic, and more intertwined than we ever dared to imagine. A galactic web of exchange, where fragments of one world travel across the stars to another. And through it all, Webb stands as the storyteller, translating the silent messages of the cosmos into knowledge. Its discovery of 3I/Atlas's vastness is not just a correction, it's a revelation. It shows that even now, when humanity believes it has grasped the scale of the universe, the cosmos always holds deeper surprises. 3I/Atlas is not simply a larger rock. It is a messenger on a monumental scale, an emissary that reshapes how we perceive our place in the galaxy. The implications ripple across science. Planetary formation models, galactic dynamics, even the chemistry of life itself. All must now account for the possibility of massive interstellar travelers. To eject a body of such size, 3I/Atlas's home system must have endured cataclysmic upheaval. Young stars are chaotic, their planets shifting, scattering debris under gravitational duress. For a body of this magnitude to be thrown free rather than absorbed suggests extraordinary instability. Perhaps multiple giant planets battling for dominance, or a close stellar encounter violently disturbing orbits. If this process is common, then every star system may have contributed its own titans to the interstellar deep, creating a vast, unseen population of wanderers drifting endlessly through the void. Survival across that abyss is no small feat. Interstellar space is not empty. It is filled with radiation, dust, and thin atomic winds. Smaller bodies erode and vanish over time. But something as massive as 3I/Atlas endures, preserving its core, locking within it the geological memory of its origin system. That makes it a time capsule, a relic of another world, perfectly preserved across unimaginable epochs. For astronomers, it's a tantalizing prospect, a chance to study alien geology without ever leaving our solar system. Future missions could one day pursue such objects, treating them as interstellar fossils carrying the chemical record of distant suns. Its gravitational presence, too, cannot be ignored. A body this large, passing through our solar system, subtly tugs on everything around it, disturbing cometary paths, shifting asteroid orbits, influencing the long-term dance of celestial mechanics. It is not a passive traveler, but an active participant in the gravitational web that binds the solar system. Even its internal structure deepens the mystery. Webb's data hints at layers of ice and carbon compounds on the surface, but beneath that, its mass suggests the possibility of internal differentiation. Larger bodies retain heat. They can form layers, cores, perhaps even pockets of liquid within. If 3I/Atlas once harbored such processes, then it was not a dead rock. It was a nascent world, a planet in embryo, cast out before it could fully form. This blurs the boundary between comet, asteroid, and planetesimal, revealing how complex and varied planetary creation can be. Its discovery also underscores how limited our previous vision was. When astronomers detected Oumuamua and Borisov, they were already straining against the limits of observation, trying to interpret faint, fast-moving specks across the night sky. That 3I/Atlas could be so much larger, yet still underestimated, shows how much remains unseen. Countless other giants may have passed silently through our solar system before we ever had the means to notice. The awareness that we may only now be glimpsing the first of many such objects is humbling. It reminds us that our understanding of the galaxy's population of wanderers is in its infancy, and that Webb's revelation may only be the beginning of a vast new field of study. The galactic perspective is staggering. The Milky Way is a living system, a grand ballet of stars, planets, and fragments all orbiting, colliding, and exchanging material. 3I/Atlas's journey proves that star systems are not isolated islands, but contributors to a vast cosmic network. Each ejected world becomes a messenger, binding distant stars through the quiet exchange of matter. Over billions of years, these travelers form invisible threads connecting the galaxy, a physical expression of the unity of creation. For humanity, that vision is profound. It tells us that our solar system is part of a galactic conversation, an eternal exchange of dust, rock, and potential life. Webb's findings even expand theories about how life's ingredients spread. If a massive interstellar object like 3I/Atlas were ever captured by a young star system, it could deliver organic compounds across unimaginable distances, seeding new worlds with the chemistry of life. This turns the galaxy into a living ecosystem, where large bodies act as couriers of complexity, ferrying the potential for biology from one stellar nursery to another. And with 3I/Atlas confirmed to be so large, the survival of those compounds over eons becomes even more likely. Finally, Webb's discovery raises a humbling question. How common are these cosmic giants? Astronomers once believed them to be rare, almost impossible anomalies. But the evidence suggests otherwise. If even one such massive body has crossed our path, there may be countless more, quietly voyaging through the interstellar dark, carrying the remnants of shattered worlds and the seeds of new ones. And as we continue to observe, measure, and learn, each revelation brings us closer to understanding the true architecture of the galaxy, an endless expanse not of emptiness, but of connection. The story of 3I/Atlas is not just about discovery. It's about perspective, about realizing that the cosmos is not static, but alive with motion, exchange, and evolution. The James Webb Space Telescope did more than expose the scale of a distant traveler. It reminded humanity of its own smallness and of the infinite, awe-inspiring wonder that still awaits us in the dark between the stars.